Discovery clears the tower.
Discovery, go and throttle up.
Discovery, roger, go for deploy. Everybody in the shuttle program, the crew is go for launch. Roger, nice to be in orbit.
We have followed in their footsteps to get us where we are today.
Five, 4, 3, 2, 1, ignition, engines full power, and liftoff of NASA Crew-8. Go Falcon, go SpaceX, and go NASA.
One Alpha.
Endeavour ascends, a beacon of human ambition. 1.7 million pounds of thrust now propelling Falcon 9 and Crew-8. Vehicle is pitching downrange.
Good morning and welcome to NASA's Kennedy Space Center in Florida. I'm Jasmine Hopkins and you are watching the post-launch news conference for NASA and SpaceX's Crew-8 mission. At 10:53 p.m. Eastern last night, that was Sunday, March 3rd, NASA astronauts and one cosmonaut lifted off for the International Space Station. The crew contained Michael Barratt, Matthew Dominick, and Jeanette Epps, along with Roscosmos cosmonaut Alexander Grebenkin, and they are now on their way to the International Space Station. Joining us tonight is a group of distinguished experts who are going to talk to us about that mission and what is in store for the crew. So starting from my left, we have Steve Stich, manager of NASA's Commercial Crew Program, followed by Joel Montalbano, manager for the International Space Station Program, and finally Sarah Walker, director of Dragon Mission Management from SpaceX. We appreciate them being here with us tonight, and this panel will be taking questions from the media in the room and over the phone. But before we get to those questions, we'll give them each a moment for opening remarks. So, Steve Stich, we'll start with you.
Thank you, and good morning, good evening to everybody. It's awesome to be here tonight after a great launch about an hour and 20 minutes or so ago. I really would like to congratulate the entire NASA SpaceX team, along with their international partners, Roscosmos, ESA, and the Japanese Aerospace Agency as well. Great to be part of this team. I think, launches like this really illustrate what it takes to do human spaceflight and to take it one step at a time, like we have all the way from the FRR, agency FRR that we had last Sunday. We took our time one step at a time each day. We fought some pretty challenging weather, I would say, over the last few days. We stood down a couple of days, 2 opportunities on March the 1st due to winds in the staging area. We made a really good try at it last night. We thought we might be able to squeeze in an opportunity, but the weather wasn't good, and so we stood down and scrubbed that launch. And then tonight, the weather held, and we had good weather in the staging area, good weather for the launch site, and we were able to launch successfully. It was awesome to listen to the crew and the excitement. You heard Matt Dominick make several calls to the ground relative to the abort boundaries going up the hill, and so it was great to hear Matt's voice. You could tell that they were really excited on their way to the International Space Station and on orbit. The vehicle is doing great. Before we came over here, we separated from the Falcon 9. That all went really well. We opened the nose cone, and that went just fine. Checked out the forward bulkhead Draco thrusters, which are the thrusters that we do the big burns with. Those all worked fine. Did one phasing burn a little while ago. It was about a 45 meter per second burn, and that went well. The crew will get a little off-duty time starting about 2 a.m. here in the morning, and then setting us up for the next big phasing burn, which will happen around 4:14 p.m. tomorrow. And then the rest of the sequence goes early Tuesday morning at 1:34 a.m. Eastern time. We'll do what's called the approach initiation burn. That sets us up for the final phase for the rendezvous and docking, and then we should dock around 3 a.m. Eastern on Tuesday morning, early in the morning. So right now, Dragon's doing well. We're excited to have Endeavour on orbit with its 5th flight. And then, we're going to set up for Crew 7 return. Once we get docked, we'll work on the Crew 7 return. The earliest return would be probably a week from today, around March 11th or so. The countdown was really smooth. We had, one item that we worked, and Sarah Walker will talk a little bit more about that. an area of the TPS around the hatch seal on the upper part that we had a little imperfection that we wanted to take extra time and make sure it was good, and Sarah will talk about that. So once again, I'd like to thank the entire team, thank our NASA SpaceX team and all the international partners, the International Space Station Program, the Flight Ops Director at NASA, and I'll turn it over to Joel Montalbano.
Thank you, Steve, and what an outstanding launch. You know, you heard how excited the crew was. We were just excited in the Launch Control Center, as well as all the control centers across the globe watching this mission. Just outstanding. Steve mentioned that we're setting up for a docking around 3 a.m., and then we'll have hatch, March 5th, we'll have hatch opening about 2 hours after that. And this crew will do a handover with Crew 7, about 5 dock days. And so that sets us up, as Steve was saying, no earlier than about March 11th. But we'll be watching weather, and we'll wait for the best opportunity to undock and land Crew 7. Shortly after Crew 7, the focus will be to SpaceX 30, the next Drago cargo mission to the International Space Station, right now targeting the middle of the month for that. And then following that mission, we'll have a Soyuz launch on March 21st, and then a Soyuz landing on April 2nd. Crew-8 will dock to the forward port of the International Space Station. They will stay docked until late August, and we have about 250 experiments in science and research, technology development, as well as commercialization of low Earth orbit. With that, a huge thanks to all the NASA colleagues who make these missions work, to SpaceX, to our international partners. Just a true cooperation across the globe. With that, I'll hand it over to Sarah.
Yeah, thanks, Joel. Yeah, it's been a great week down here at SpaceX and Kennedy Space Center. I'm glad the clouds finally parted for tonight's launch. And we're proud to have just launched, as everyone has said, Crew-8 from Launch Complex 39A. It marks SpaceX's 13th human spaceflight mission. And I was thinking about what to share with you guys today. I was struck by this being the 5th flight of this Dragon spacecraft. It launched on the 5th anniversary weekend of Demo 1, which was the inaugural Dragon Crew flight. And it's docking on March 5th, a couple days here. And its crew marks the 50th crew member that SpaceX has sent to space. So in just a handful of years since Bob and Doug flew this very spacecraft, actually, on Demo 2. So this spacecraft, which its first crew named Endeavour, has now flown the Demo 2, Crew 2, AX-1, Crew 6, and now Crew 8 crews to space, for a total of 466 days on orbit and counting. So I'm glad to report we've inserted into a nominal orbit tonight. I think Steve mentioned also Dragon and the crew are on their way to the space station. We anticipate arrival around 3 a.m. Tuesday morning, Eastern Time. It was an extremely quiet countdown on console tonight, one of the quietest that I've ever been a part of. But Steve mentioned the area of interest that we worked was around 45 minutes. The engineers who are doing the closeout photo check once we close the hatch, they take detailed photos of the perimeter of the hatch and that final seal. And as they were doing those reviews, they noticed an area of interest on kind of the upper section of the RTV, which is kind of a top coating on the hatch seal, that they wanted us to take a look at. So we looked at the photos. Eventually it was determined that the size of the defect or separation of that RTV seal was within the qualified limits of the design. So that was ultimately the flight rationale that cleared us for launch. There were a couple of other areas of conservatism that further, I guess, increased the confidence. This is one of multiple redundant seals in this area. It's kind of a top coating over the pressure seal, which is then over the main seal for the hatch. There's also a very low heating region for the vehicle. And actually this material expands under heating, and so we expect that actually a defect of this size would self-heal during the launch process. So, but we spent some time consulting with NASA experts and the SpaceX experts back in Hawthorne, and ultimately decided we felt comfortable and confident safely proceeding into today's launch. So it's amazing to think that SpaceX has now launched 45 times to the ISS. We've launched enough together that I think we can be really proud of what we've accomplished, but I think not enough times to take for granted just how much it takes to get this right every single time. A lot goes into that, and we know what the stakes are, and I'm really proud of the team and the clean execution that I saw tonight on console. I think there's an incredible team of engineers at both NASA and SpaceX over the last many months that have been laser focused on leaving no stone unturned as we stepped methodically towards tonight's launch. Yesterday night's launch. It's early morning now. Joel mentioned that once we dock to the space station in just over 24 hours, our next big event will be bringing the Crew-7 crew home to their families in about a week. And that's no earlier than Monday, but as always, we'll look at the weather as we're proceeding through the week and pick the best opportunity to bring the crew home. And then we're excited about the cargo launch that's coming up right on the heels. We actually loaded cargo earlier today into that vehicle, and we're in final preparations for launch. So huge thanks from SpaceX to all the NASA and Roscosmos and 45th partners on close collaboration again on this launch. It's really an honor for all of us to launch human spaceflight missions and to support all the science and research that the crews aboard ISS conduct. So thanks for letting us be a part of it.
All right. Thank you all for those opening remarks. So now we're going to open up the floor for questions to the media in the room. If you have a question, please just raise your hand and we will get you a microphone. And to those of you on the phone, please press *1 to enter the question queue. So we have a question right here in the center aisle. We'll get you a microphone.
Thank you. Hi, Nick Alexander for Space Scout. I had a question for Sarah about the items of interest on the seal. Is this perhaps related to the age of Endeavour as it's gone through multiple flight cycles, or is this something that may have occurred during handling or final checkout? Thank you.
Yeah, this is actually newly applied coating every time. So, yeah, so it was just the nature of the application process that there was a minor defect there, and then we had the engineers evaluate the kind of acreage of the defect and make sure that that was within the limits of what that system's qualified to withstand. So, yeah.
Thank you, Sarah. Another question right here in the center aisle.
Hi, I'm Aaron Cooper with CNN. Can I get Steve and Joel to tell me a little bit about how optimistic we are we'll see a Starliner launch next month, how important that is to the programs? And Joel, anything we can also know about the leak on ISS?
Yeah, thanks for the question. Yeah, the Starliner launch is extremely important to the commercial crew program, to the ISS program, and to NASA. I was just over at the Boeing facility, I guess it's Sunday last week, on Friday. That spacecraft has been rolled into an area where they do the propellant load, and so it's sitting there ready for propellant load. What we've been doing is kind of watching how we progress with the Crew-8 launch, and then the CRS-30 mission, and then we'll decide when to load propellant. But that mission is on track right now. We're looking at kind of the end of April. It really is based on the sequence of events that we talked about before. We have to launch Crew-8, bring Crew-7 home, then launch the cargo mission, which Sarah talked about. Is already that vehicle's fueled, loaded with cargo, ready to launch. That has to come back, and then we'll do a port relocate. We're on the forward port, as Joel talked about. We need to move up to the Zenith port because Starliner, just like we did on Demo 2, is going to dock to the forward port. So right now, the vehicle's ready. We're closing out the certification. I would say the thing that's pacing when we go fly is really this complicated, sort of traffic management. And I'll let Joel talk about the leak.
Yeah, I'll just have one thing on Starliner. It's very important for the agency to have two providers that are delivering crew to the International Space Station. And so, we're excited to have Boeing and looking forward to having these missions where we have one SpaceX and one Boeing mission every year. On the PRK leak, no real changes since the last time we talked. Right now that hatch is closed, and the hatch is scheduled to be closed until early April.
All right, thank you. We have some questions here in the very front.
Hi, everyone. I'm Andrew Donovan from News Channel 9 in Syracuse, New York. We traveled here to tell the story of Jeanette Epps. I'm wondering, Steve and maybe Joel, if you'd weigh in about what she means to the crew, her hometown pride. We heard the Syracuse shout out already when she was leaving the atmosphere. Just what she brings to the team, her background, her upbringing, her challenges being, previously assigned to a mission and now finally up in space.
Yeah. For me, it was really exciting for me to watch her walk out today and see the excitement on her face as she made her way out to the launch pad, getting into Dragon, and you could just tell once she got in orbit the excitement in her voice. So, we're really excited to see her fly. I think she's going to do a great job while docked ISS, do a lot of great science, and I'll see if Joel has anything to add.
Today we had 3 rookies on the mission, and anytime you have rookies, the excitement is amped up a lot, and it's awesome to see them, yipping and yapping and yelling and screaming. It is, and then once they get in orbit, it doesn't stop, and so they really enjoy it. They love being. They will love being in space. They'll love being on the International Space Station. So to me, it's exciting every time we have a rookie on board.
Great, thanks so much. We have a question right there.
Bill Harwood, CBS, and this is for Steve. About the SEAL thing, does NASA have the authority to disagree with SpaceX in a case like this and stop a launch if you wanted to, number one, or is this a SpaceX call, period, on a system as subtle as this, and they're the ones that have the data? That's number one. And number two, what is your approach management style? Because when a problem like this crops up with just a few minutes before launch, I mean, no matter how you look at it, there's a lot of pressure on you to make a decision quickly, because you were on the verge of delaying fueling, which would scrub the launch if you didn't get that done, and then you're down to 10 minutes to launch before you resolve it. So just from a management standpoint, how do you guys deal with the last minute thing? You're smiling, Joel, because I mean, anybody that watches one of this is going like, how do we know that, you guys are really doing the right thing, to put it? I mean, I know you are, but it raises that question when you're faced with a decision like this in the last minutes of the countdown.
Yeah, relative to the first part of your, good question, Bill. Relative to the first part of your question, absolutely, NASA has the authority to stop the launch, and if we see a course of action that we don't necessarily think is right. I mean, a few flights ago, Crew-6, right, when we had the T-tab incident where looked like it wasn't filling, we couldn't get ourselves convinced that we would have a good start in the engine. NASA and SpaceX worked together, and we decided that it wasn't a good day to go fly. So we actually have that authority at any point in time if we see something that we don't like. And SpaceX polls us multiple times in the countdown, polls us as late, in this case, as 5 minutes prior to launch. NASA, are you still ready? Are you still ready to proceed? For this particular case, I would say have a lot of experience I do from Space Shuttle, and this was a thermal seal on what we would call the leeward side of the vehicle, right? This is the side of the vehicle that doesn't see the highest heating. So we looked at this particular defect in the seal. It's a thermal seal. It's made of RTV, as Sarah says. So that RTV generally will heat up during entry and seal any kind of anomaly. The engineers went back and looked at the heating in this particular area, on the top part of this hatch seal, and that heating wasn't anything that would be of concern with this size defect. We also went and looked, we've flown a lot of, I would say, experiments in the TPS on cargo flights where we put some defects in the TPS, and we've looked at those on this side of the vehicle. We looked at that data in that time frame and said, hey, based on much bigger sizes of defects that we did as an experiment, that this would be no concern. We had our TPS experts involved, a couple of guys that I have utmost confidence in from the Space Shuttle program. I listened to the whole conversation that they had back and forth with SpaceX and their rationale for proceeding to launch. And I thought that they had exactly the right rationale for this size little imperfection in the seal. It really doesn't, the hatch seal per se, the pressure part of the hatch seal is way underneath the vehicle, right? So this is in an area of a TPS seal. And so, they had great rationale. Our guys agreed with SpaceX. They came to the really good conclusion. You're right, the clock is counting, but we could have backed out at any point on down inside of even a minute. So.
Is this something that was caused when the hatch was closed, or was this something that was there all along, they just didn't spot it before? Or?
Yeah, it's part of the hatch closure process. So it's normal that around an hour before launch, we're reviewing all the photos of that final operation, and then an engineer flagged it. Yeah, and I would just echo what Steve said. It was really a privilege to listen on the nets, the kind of methodical nature that the teams worked through. Our experts back in Hawthorne and the NASA experts back in Houston were immediately on the phone and on the nets together, working together. And then there's also NASA operators here with us in launch control. And one thing that I thought was really neat is once our Vice President of Dragon Engineering got on the nets and explained his flight rationale and why he and his NASA counterparts were comfortable proceeding, the NASA operations manager said, you know, you come to all the same conclusions that our team here in the room had just independently come up with you. And so then we corroborated one another and agreed to go for launch. So it was really a neat thing to watch happen.
Yeah, the voice loop communication was outstanding. They talked about, hey, we're about to start fueling in these minutes. We have this much time to make a decision if we think we're going to get there. The launch team, the SpaceX launch team was just outstanding on this.
Thank you so much for tag teaming the answer to that question. We do have someone joining us on the phone now, Chris Davenport of Washington Post. Chris, are you with us?
Yeah, I am. Thanks so much. Quick follow-up to Bill's question when you talk about this defect or the crack. Like, how big is it? Do you have a sense of the measurement? And Sarah, you said it was within the, I think, qualified limits. But what are those? Meaning, like, if you have a crack or a defect of 1 millimeter, it's okay, but 2 is a no-go. And I guess, and Steve, I'd like you to weigh in here as well, since you're tag teaming the answers. I just want to get a sense of your level of concern going through the countdown when you noticed this. Was this like a close call, or were you fairly confident early on that you felt like this was okay and you could go forward? Just want to gauge your level of concern. Thank you.
So to answer the question on the size, so we estimated this square acreage of this defect to be about 0.02 square inches, which is less than half of what we are required to qualify this system to. Holes or cracks or other defects, about 0.05 inches, I believe, is the qualification limit. Yeah, Steve, if you want to answer the second half of the question.
I would say when I first saw the picture of this defect, my experience told me it would be acceptable to fly based on where it was. Again, it was on the lee side of the vehicle. It was a very small defect. It was in an RTV seal, which is a room temperature vulcanized material. It can take high temperature, and then when it sees temperature, it kind of melts over. So that was my initial intuition, is that an engineering judgment is this would probably be okay based on my, also it was on the lee side of the vehicle, which doesn't see the high heating, in an area where we know the flow pattern really well. But I don't say anything at that point, right? I let the team go work through it and see what conclusions that the SpaceX TPS experts and the NASA TP experts come to. They worked through it over a number of minutes, chatted back and forth, went back and looked at the qualification. This particular seal has a bond verification, so when you install that seal, they pull on it to make sure it's rigidly attached. And then beneath it, there's another secondary pressure seal. And then they talked about, could you get any flow down? Would there be any potential to get any flow inside any areas? If so, what would that mean? Is there any pressure source to draw flow in? So I listened to the whole conversation, and based on the way that the engineering team went about it, and also looked at other vehicles, did they see any charring in this area? What's the heating like on previous reentries? And then also the abort cases, should we get into one of those? And so I was able to get comfortable, and our team was able to get comfortable that this was a defect that we could go fly.
Thank you so much for answering that. All right, we'll come back to the room now for any follow-up questions. We have one in the back there. Just give us a moment. It might take us a second to get you a mic. He's on the camera in the very back. There we go.
Yeah, thanks. Hi, Will Robinson-Smith with Spaceflight Now. Question for Sarah. Since you all mentioned the CRS-30 mission, which is set to fly off Pad 40, you can give us an update on how qualification for that is going, and particularly we saw the emergency escape system being tested with what looks like some type of slide mechanism. Can you explain exactly what that is, how it works, and will you test that with humans before it's human rated? Thanks.
Yes, and that qualification is complete, which is really exciting. Yeah, so Pad 40, you guys are all aware that we've been trying to build up redundant Dragon capability on our 2 neighboring pads, which is really exciting. Remember, Pad 40 is our high-rate pad, and so it's most efficiently used for satellite launches. I think we've gotten the launch-to-launch turned down to just a couple of days, which is really exciting. But it gives us the flexibility that if there's ever a traffic conflict on 39A and two missions have to launch at the same time, and one of them's a Dragon, now we can move over to LC-40 and prioritize both of those missions. So super exciting to have two pads. The emergency egress system is very similar to the slide wire baskets that were heritage NASA design over on 39A, which we use. The idea is you want to get people away from the top of the tower, both the pad closeout crew and the crew themselves, as quickly as possible. And so the primary egress route for most emergencies, well, let me back up. At one point, as soon as the rocket begins to be fueled, the primary mode of egress is actually the spacecraft itself, which can carry the crew away to safety. Before that, there's a couple of other different types of emergencies that could happen on the pad that we want to protect for. And we have an elevator that's the primary, and it's a very unique elevator, fire safe, lots of unique launch pad related safety features on it, is the primary mode of egress. And then we have similar to the slide wire baskets, another kind of chute escape system on LC-40. So we ran a number of tests this week in a lot of different configurations, including incapacitated crew member. Could you send a stretcher down this, essentially a slide? You may see some test subjects from the qualification campaign on this panel, and we completed all the required. Completed all the required configurations. We looked at in a spacesuit, what if the spacesuit is a little bit wet because of a fire response up on the pad? And so, yeah, that was the last piece of the system to come together. It's checked out now. I think also this week we got the final external approvals as well. So I hope we get to fly a Dragon soon on off of 40.
And a couple of things. The chute system that Sarah talked about is kind of a system that's used in a lot of industrial applications. A lot of different buildings use a similar kind of system. So it is a very simple system that the company that SpaceX worked with has installed. We were out there looking at it the other day, and it's a very simple system, simple to use. And as Sarah said, we had NASA fire crash experts using that system, in addition to some of the Cape fire experts going down that with our ground and mission support personnel, and also health and medical engineering team out there doing about 3 or 4 hours testing. And everybody that has used that system says it's really safe, really easy to use. So it's a pretty innovative solution, and we think it's going to be really good for crewed missions down the road.
Great, thanks so much, Sarah and Steve. All right, back to the room. We have another in the center aisle right here.
Hi. Yeah, this is for Joel. In the last couple of days, we received a report about the status of Zvezda, looking at the leak rate that has increased on the Russian segment. This is kind of a two-part question. So, how much risk is there to crew right now? Actually, three-part question. How much risk is there to crew right now? Are the hatches sealed in that area? And what is kind of the action plan for going forward with that leak and increased leak rate? Thank you.
Sure. Right now the hatch is closed, and it's been closed since, I believe, middle last week or so. The plan is to keep that hatch closed until early April. Right now we're working with our Roscosmos colleagues on what is the plan. When you go into that area and open that hatch, how long do you stay there? Do you keep the hatch open at night, et cetera, et cetera? But we got a little time to go work that. But right now there's not a safety issue with the crew. That hatch is closed. When that hatch is open, the leak rate is about 2 pounds a day, a little over 2 pounds a day.
Thank you, Joel. Back to the room for additional questions. Another in the front row here.
I don't come often, so I'll take advantage. What's the process like for adapting to life on the International Space Station?
So the first week when the crew members are on board, we give them an hour of kind of relaxed time or time adaptation time. We don't fully schedule them that first week. These 5 days, they'll be handing over with Crew 7. So Crew 7 will be telling, hey, here's the lessons learned. Hey, when the ground calls up and says you have to do this activity, here's some of the things we learned to make it easier or more time efficient. And so that first week is adapting the space. So you'll have a fluid shift of the body, and so that takes a couple of days or so. But getting with the Crew 7, understanding the lessons learned, and then, like I said, that first week we schedule them an hour less, and then after that, we put them to work.
All right, thank you, Joel. Any other questions here in the room? All right, seeing no hands raised, I'll take that as a cue for us to wrap things up. I know that it is early or late, depending on where you're watching from. So I want to thank the media for joining us here in the room, and especially those of you that also ask questions over the phone as well. I want to thank our panel, Steve, Joel, and Sarah, for being up late to take our questions. Before we let you go, we do want to remind you about docking. So Crew-8 is well on its way, and docking to the International Space Station is set for Tuesday. That is March 5th at approximately 3 a.m., and coverage is scheduled to begin at 1 a.m. Eastern on Tuesday morning, and that will be on NASA TV. So thank you again for everybody that joined us today, and until next time, go NASA, go SpaceX, and go Crew-8.
Inside the suit-up room, where we see our 3 astronauts and 1 cosmonaut. And the point of this card game is so that the commander loses, to use up his bad luck. Here they come, Crew-8, taking their first steps outside before their journey to the International Space Station. Crew is departing from the Operations and Checkout Building across Kennedy Space Center to Launch Pad 39A, walking over to get a good look at their ride to space. Commander Matthew Dominick, pilot Michael Barratt walking down the crew access arm.
See, the techs are making sure their helmet is protected on the way in.
Jeanette Epps, Alexander Grebenkin are 2 mission specialists for Crew-8, walking on that sticky tape to grab anything before they ingress as well.
We see 4 seats in the launch position. They're closing the hatch now.
Full power and liftoff of NASA Crew-8. Go Falcon, go SpaceX, and go NASA.
Endeavour ascends, a beacon of human mission. 1.7 million pounds of thrust now propelling Falcon 9 and Crew-8. Vehicle is pitching down range.
It's a new era.